Okay guys, welcome back to the Forensics Detailing channel. We've got engines in bits here. Well, flat, not that, but look, we've got the valve cover off. That's a different story. But today we're talking about Porsches. We're talking about Porsches, and if you've been following the channel, you've been hearing me talking about a slight performance issue I have on my car where it's producing about 270 max brake horsepower, but it's suffering from a noticeable loss of high-end power north of 5,000 revs, where it's flatlining, dipping, and then achieving peak revs right at the end, which if you've seen the Surrey Rolling Roads video on the main channel, you would have seen. So we're still investigating that, and we're starting to think ECUs now. We're starting to get into ECU territory, but we're not quite there yet. And there's a few things that I wanted to investigate here today, and that's what I want to talk about. And in particular, I want to investigate resonator flap activation. Now, someone put me onto this in the comments because I thought the intake system on this car was effectively a dumb intake. So in other words, a throttle body with an idle control valve bypassing the throttle body into your air intake system, plenum, you know, and then your spiders straight into your cylinders, and two sets of three cylinders, bank one and bank two, air goes in. But what you also have is an interconnect pipe on the back section of the intake system, which cross-links the two intake spiders. And in the middle of that cross pipe is a flap, a bit like a throttle body, which actuates and closes the pipe. And this is done for resonance. So this is my understanding. You can chirp in if you understand it better than me. When you achieve resonance, if you had a little gap in a window sometimes when you're driving a car, you can get this like, and it gets really loud when it resonates and the airflow resonates. You can get resonance, or you want to achieve resonance at certain points during the rev range, I believe. So if you achieve resonance at certain points, you'll get better engine performance. It's bloody complicated, this why you would do that. I don't think I've ever seen it before, but the way I think this flap works, and this is why I'm investigating it. One of the guys in the Aero Club, James, had a problem with his flap and was getting poor performance north of 5,000 RPMs. So the way that this works, so if we have our three intake pipes here, there's our intake bank one, our intake bank two, and our tubes going into the cylinder. And let's just say our throttle body there, so air in here and MAF here. It's not very good, and that's bolted onto the side with rubber things. And then your resonator tube there and your flap in there, yeah? So you're getting an idea of how it works. Now, this is on an axle, and on the back of the axle is a vacuum actuated arm. Okay, so this arm, it's probably best to draw the arm there. This arm there connects to the end of that axle. This connects to a vacuum pipe, okay, that connects to a switch. There's a little rubber elbow that connects to a switch here that's right by your alternator. You can get at it and you can disconnect that switch. So I think that's an open and close valve, effectively. Correct me if I'm wrong on that. So that's an electronic, tiny little one of those switches. Then that pipe there goes down, this is my understanding, to I think there's a three-way connector, okay? That connection pipe there, I'm doing it, let's do it. Actually, let's do this connection pipe here, goes back into the throttle body. There's a one-way valve on this, which only I think lets airflow that way through, so that it gets a vacuum, or it gets an airflow. Oh no, it must be the other way through. Sorry, it must be that way through. So it gets an yeah, of course it is. It gets an airflow that way from the suction of the engine. So it provides like a boost, was how James described it, or a regulation vacuum. But then here you have that's Dan. There you have a vacuum reservoir, which is just a plastic doodah, you know, a plastic reservoir that is connected to a switch here, I think, close to it somewhere. And then I think you have a pump or something, some way of it drawing a vacuum circuit. So that's a switch as well. So the symptoms I'm seeing is I wanted to prove I had a good vacuum, and this was actuating. So I probed in with a camera, a GoPro on a stick that I've got over there. I probed in and I ran up the car, and within 2 seconds I see that arm actuate and the flap close. Okay, so I know that this whole vacuum system is working. I did also smoke test this vacuum system from here, and it's good. So I smoke tested into it. You know, and really let it build up pressure, and it was solid. Yeah, so I think I've got a good, I know I've got a good mechanical vacuum, okay? The thing is, I've done this test again today where I've heated the car up and it's running at full temperature. I start the car, vacuum closes. I then rev the nuts out of the car, go through the entire rev range, and I don't see the resonator pipe opening like at 5,000 revs or whenever it opens at whatever range. I believe it's supposed to be open at idle, close between 2 and 5,000, something like that, and then open at high revs. I'm not seeing any of this change. So today, Dan's brought his car round, and I'm going to probe the resonator system on it to see how his functions. He's just turned up and his car's hot. So that's one test we're going to do, and this is all about understanding the car as well. There could be something going on that would explain why mine just closes. It could be some parameter that I don't understand how the system works. So that's why I'm looking at Dan's. But it also occurred to me that if any of these switches failed, in particular that switch there, and that switch was always open, it would build a vacuum instantly, and it would lose its ability to control itself if that switch was faulty and stuck open. I can run tests on the durometric to open and close that, but I have to have the engine running. When I run the tests and look at airflow, well, actually airflow's not good. I just run the test and I can use an activation to open and close that. It crashes the durometric because I think I've got a driver problem. So that's another thing. But yeah, it's weird. It must be open if that closes, if you get what I mean. The vacuums, that must be open to activate the vacuum. So I can't see it ever changing. So something's knackaroonied for me. So that's why we're going to jump right into go and see Dan's Timeless Classics, who's probably outside now. Look at my probe. So I'll show you how to probe this. In fact, let's take Dan a microphone and I'll show you straight away how you probe this. Because it's a useful test, and I didn't want to go and, I'll probably only ever do this once. So you need a GoPro, a long ruler, you can see how I've done it there, and you need a small torch that's quite powerful. It does help. So let's go find Dan. Let me tell you something. Let me do it, going straight into the video.
Yeah, straight into the dude.
You pop the
collar.
So this car, we're also going to do some math testing on this car as well, because I still think I'll talk about math in another video, but it's interesting. So if you want to ever probe this, pop that out, get your camera in here, right the way in there, yeah? You have to fiddle around with it, spin it round, right the way in there till it's underneath. There's one, that's the initial Y pipe there, and behind it is that other pipe that I'm talking about, and the activation for it, the actuator, the valve actuator is on the back, that you've got to look at the arm, and get your torch in here on that, see that far between the second and third, the last two arms, and get the torch across until all in there lights up, and keep hunting around till you find it. There, interesting enough, is the switch that I'm talking about. That pipe there feeds the resonator flap actuator. So if you pop that off, you will, in theory, open your valve. Okay, it has to be under vacuum to seal it. So I'm interested what goes on with Dan's. And that other pipe there goes down to the vacuum pump system, which is actually, the doodah for it is behind the alternator, that canister, so you're screwed. If you ever want to get that off, you might be able to do it if you take all the Y pipes out. So our next objective is to probe Dan's and figure out what normal operation should look like on this car. It's up to temperature as well, so we'll be back. So let me tell you something, we're very excited here. Our little brain cells are... Dan's struggling with this more than me. I've got this. Come in here. Come over here.
I've got this.
Dan's sort of almost got it. So we got some really, really interesting results.
The results, I didn't wear my white professor overalls. I was going to do the hair all nutty and go for the full professor look.
We got some interesting results because what's going on with Dan's car is the opposite of what is going on with my car. Okay, so let me just write this down. Let me tell you. Oh no, I got a green.
Let me tell you something.
CGA, that's Dan. Oh, let's just write Dan. Dan and John. Like a old 60s folk pop band.
Dan John.
So Dan starts his car on idle. Okay, both cars are hot.
Yeah.
So they're warmed up. Dan starts his car on idle.
This is like one of them storybooks. Dan has £5 and walks into a shop and buys 9 apples.
His resonator flap does not activate on idle. Okay,
right, so it does nothing.
So it's open. So Dan's resonator flap is open. I start car on idle, right? Mine closes instantly as soon as the vacuum forms within seconds. That doesn't happen on Dan. Dan revs, and when he gets north of 3k...
Well, it was north of about 2.5, so as you're coming up to 3k...
Yeah, a bit of lag. So somewhere between 2 and 3k, Dan's closes. We don't want to rev them up to like 6,000 revs because my neighbours will go nuts. But that, as far as I know, is good. Then when you get to 5 or 6,
we're assuming
open again.
It opens again. We're assuming.
Yeah, so that we'll just delete that line because we don't know what's happening. Mine, I rev, and I've been up to 6,000. I've been all the way through the rev range.
And
mine,
it's doing nothing.
And it stays closed
all the time.
But closed means the vacuum is activated. Yeah. So basically, the symptoms I've got on mine, as soon as I start this car up and this vacuum forms, I generate a vacuum to my valve and it closes it. There is only one fault that could do that, and that would be that switch being stuck open. No other fault would do this, because on Dan's car, we put that pipe into here and bypassed it, and he then behaves exactly the same as mine, because he's just got a constant vacuum pull closing the flap.
Closing the flap.
So
as soon as you start the car, it creates the vacuum that closes the flap. The switch stops the vacuum from closing the flap. The switch decides whether it's open or closed.
Yeah, well, the DME, the computer must tell it. So unless I've got a problem communicating to that, which could be possible.
Yeah, potentially not the switch of communication.
Because I've been playing around with this on the durometric. I can activate that switch, I think, when the engine isn't running without crashing the durometric. So I can test that switch potentially to hear if it's clicking or not. But I don't think that switch is working, and I think really I should probably just swap that switch out. I could swap yours for it, but don't want to play around with your car.
The other theory we're looking at here is that, so that's your pipe, yeah? There's your two intakes, there's your plenum. So all the cars, the flap, we've seen these flaps, they're like that, they're horizontal, they're open. They're fully open.
By default. So if there's no pressure on it, it's open.
It's open, it's full open by default. I start my car, it doesn't change. No. You start your car, it closes.
Yeah.
Which is not what you should be doing because it doesn't need to close yet.
Which means that must be open, that switch must be knackered.
My car then closes once the revs increase to stop this resonant noise potentially.
Well, for resonance optimization, so it feels like you achieve resonance at low revs, so open flap is better.
Yeah.
And then somewhere in the middle, it wants to alter that resonance and that air bang.
And it closes it off.
Closes it, and then at high revs, it thinks, right, I want it to do that thing again.
That's the only thing we can't test, but without revving it higher.
We don't need to.
But in theory, we should get right up that rev range, about 5,000-6,000, and that should reopen to maximise airflow and air movement at that point, not caring about resonance.
James, one of the guys with Aeros that I've been speaking to, thank you, James, for your help with this. He had a cracked reservoir, so he couldn't build vacuum here. So he had a tiny bit of vacuum if he put his finger there and thought it might be working, but that was cracked. So he wasn't able to get vacuum. So his pipe was permanently open, and he noticed power loss after 2000. But interesting though, because really,
so his was permanently open.
It would have been
because it's not getting the vacuum to close it,
which is the opposite of mine.
Yeah,
mine would cause all sorts of problems. But yesterday I was looking at airflow, and I wanted to see if airflow was affected by this resonator flap into the cylinders, and it isn't, as far as I can tell. I've still got crappy airflow. That's my one concern. Is my low airflow is something we're going to talk about in another video. Low airflow, metered airflow. It's a whole nother complex ball game.
But if we talk about your power problem, because that's what this whole game was.
But this is a fault that this is definitely a fault of mine that needs to be fixed.
CGA's power band is like that.
Yeah.
So it's nice and steady. It drops off a vario cam and it recovers and picks up, and its max power is up here in the late 60s. Yeah,
yeah, something like that. Yeah.
Your car does exactly the same, but dips more.
Yeah.
And just doesn't really recover.
Yeah, you got it. Yeah, it's a good plot actually. Yeah.
If we think about that, having to reopen between here and here.
Yeah.
And it's not. You've got to think that there's some science in that.
I don't know, but my gut feeling is that my fault with the resonator flap is not causing that. I think it would make very little difference. But it's still a fault that needs to be fixed.
But you're saying that this flap is designed to reopen after 5,000
Yeah, but only
RPM,
for resonance. Only for resonance.
Yeah, but you're talking about two great big air chambers, two pipes that cross across the air chambers, and you are closing.
Yeah, but it doesn't.
One of those
your air comes in through here and it goes through these chambers and then down into the thing.
Yeah, I get that. So it's constantly sucking air.
It just affects
like that. So why have the crossover?
Because it's just there to optimise resonance. So without it, if you didn't have that in there, your air's coming in and it'd be going a certain frequency. And that won't be optimised, so it's doing something clever beyond what we can understand.
Yeah, the Germans have done it. Why? Is it emissions? Is it intake noise?
It's to optimise resonance efficiency, which will have a slight impact on performance. But I reckon you'd be talking like, Jesus, I don't think you'd be talking 10, 15 horsepower, but you could be.
But the only test you can do is to get this switch changed.
Yes.
Make sure your car does the same as this car.
Yes.
Same as CGA, so we can confirm that it does do that.
Yes.
And then go back to the rollers immediately without doing anything else, because you don't know what that's changed, and see if there's any
I don't want to get ahead of
there.
myself, but if I go and replace that switch and I've got the same problem, then it's a controlling issue.
Yeah.
Either
from the DME to the signal.
And could that be that map that's applied to the car? Does that shut down? This is the thing. I think it's had a Revo map, not an Evo map.
Yeah.
A Revo map.
Yeah, Revo are well known.
What the hell that does? Does it? I doubt it would interfere with this, but it's possible it could do. I doubt it would. I think it would just change.
It may have
fueling.
interfered with it by accident, by a default somewhere down the line.
It just wouldn't.
Does the MAF have any input in the information?
They would have to assume a stock
to
system, and they wouldn't play around with that, I think, but it wouldn't matter. The other symptom I've got here is that this MAF that sits just in front of here is reading 45 kgh at 2k revs. That's low.
Yeah.
And that's the next thing we're going to test, right? And that's got nothing to do with resonance. I've proven that already. And my readings, I don't know if I talked about this, match what the DME will present if you don't have a MAF connected. So the default guesstimates of flow rate that it will present, that it will assume it's using if it can't read your MAF. So if you had no MAF.
Yeah.
So in other words, my MAF readings look the same when I disconnect the MAF. My MAF, it must be working, because when I disconnect, I get a little change.
Yeah, it does.
But my airflow readings don't change, which makes me wonder if my MAF, if the serial or the connection port on the MAF, which I think is pin 1, which talks to the DME, isn't working, and it's not able to talk to the DME, but it's still got voltage power, so I'm not getting an open circuit alarm saying the MAF's knackered. We're going to prove that now. And you guys follow us in the next video when we talk about MAFs, because I've been doing a bit on
2
maths.
2 is 4. Minus 1 quick 3.
Maths. Yeah. But cheers, Dan, because we're making progress. This is why I needed CGA. And
this is why you needed my intelligence and you needed my brain to come here and function.
Half the problem is if you've got a broken car and you're looking at it,
you
trying to work
car
out,
to compare.
and there's no information on this resonator flap. Even AI can't really guarantee to explain how it works. So you get a working car, you compare it to yours, and then you get that you start to understand how the system works. So I think I understand that. I haven't got that diagram 100% right, and I was a little bit unsure of this. I think this is a little pump on the side of the engine that pulls on this. I don't understand why you have 2 switches as well, because you might as well always have your vacuum build up and just control it there. So why would you have another switch there to open it? There is definitely 2. There's a primary and secondary switch. I don't understand why you'd have a switch there. I don't understand. Why would you have a switch down there?
We'll have to find out next week when we drop another engine out and we look at it again. But with an engine in front of us, you can maybe see the layout.
Oh, I think. Because I think it creates a vacuum, and then probably it can maintain the vacuum with just the drawer there, possibly. And then maybe when it needs more suction, I don't know. Anyway, that's it for this video. Yeah, my brain's already struggling.
Fried.
Guys, we just swapped this valve around and put Dan's one in my car, and then suddenly, after swapping it, it works as it should work. So this is stuck open, in my theory, because it's
faulty. That's faulty, without
yeah,
doubt.
that's faulty. Yeah, because it's working normally now.
So now your car is doing what CGA does.
Yes.
It is open. You start to increase revs, and it closes. You start to increase rev and it closes. So now the theory you need to go and test on the road is to drive the car fast, give it loads of beans, get it right up at 5-6 grand, because it should now open.
And you get that boost then.
And you should feel like should feel when you come off aero cam, you should feel like a little bit of like that CGA's got that extra little bit of energy at the end.
Yeah.
Go and see if your car's got that now, because if it has, then
it could be fixed. That could be the fault. This is a good thing. So we definitely found a fault.
There's definitely a fault.
We've also, we found a fault with the idle control during the valve gasket with the smoke test, and that's fixed. Yeah. So we're finding things and fixing things, which is good. And who knows? Because it's only a subtle amount of power, and it could well be this. So
yeah, we're not talking about 10 horsepower, 10% here. We're talking about 5%.
Yeah, and it just could be that. It could be this. So that's good, guys. So well, end the video here.